Hello class, today we're going to go ahead and do section 5.4, day 2. So what we're going to talk about today is complex numbers and what they are. Complex numbers include imaginary parts, so there is such a thing called imaginary numbers. So let's go ahead and just look at example D from from example 2. Okay, so we're looking at D. So in order to solve this, I noticed there's no x term, so I can solve by square root. So I would subtract 48 from both sides. I have 3x squared is equal to negative 48. Divide by 3, and so I would get x squared is equal to negative 16. From this point, I would take the square root on both sides. So I would have x is equal to plus or minus the square root of negative 16. And now you guys are thinking, well, you can't do that. I've been told I can't take the square root of a negative over and over again. Here's where I changed that thinking. You can take the square root of a negative. It is called an imaginary number. Okay, imaginary numbers. A French mathematician, René Descartes, proposed that a number I can be defined such that I squared is equal to negative 1. Okay, it is also defined that I is equal to the square root of negative 1. Okay, so I can actually simplify this, and it is what we call an imaginary numbers. So it is not a real number. So x is equal to plus or minus the square root of, well, I can rewrite this as negative 1 times 16. So x is equal to plus or minus, well, the square root of negative 1 is I, and the square root of 16 is 4, so 4I. And this is an imaginary number. Okay. Here is another example. If I wanted to solve this one, I would subtract 2 from both sides. I would have 2x squared is equal to negative 2. And if I go ahead and divide, I would get x squared is equal to negative 1. And then lastly, if I take the square root, x is equal to plus or minus the square root of negative 1. And the square root of negative 1 is the same thing as I. So in this case, x is equal to plus or minus I. So example 3, we want to simplify square roots of negative numbers. So these are going to be complex numbers. So in order to do this first one, I think the same way as I did before, except for I have a negative 1. I would say, well, what are my perfect squares that are in 18? So I know that I would have, first of all, square root of, it's going to be negative 1 times, well, my perfect square in 18 is 2 times 9, so my perfect square is 9. Now I would take the square root of each part. The square root of negative 1 times the square root of 9 times the square root of 2. The square root of negative 1 is I. The square root of 9 is 3. Usually we write the 3 in front of the I. And the square root of 2 is not a perfect square, so I leave it as the square root of 2. And there is my square root simplified. I go ahead and I look at B. Same idea, I have a negative. So I would break it apart. I would have negative 1 times, well, what are my perfect squares in 125? Well, 25 times 5 gives me 125. And then I have an x to the 5th. Whenever you have exponents, I like to think about them in terms of even. So think about the biggest even. So I can rewrite this as x to the 4th times x. Because if you think, well, x to the 4th times x to the 1st, I add those, I get back to x to the 5th. So then I simplify. I have the square root of negative 1, which will give me I, times the square root of 25, which is 5, times the square root of 5, which is not a perfect square, so I just leave that as square root of 5, times the square root of x to the 4th. Well, I can essentially just, because remember, the square root of x is really something to the 1/2 power, so I take 4 times 1/2, which gives me 2, so x to the 2nd, and then the square root of x, that does not come out. So I would leave that underneath the radical sign. So just rewriting, out in front, we typically have 5i x squared, and then I can write underneath the whole radical 5x. There is part B for number 3 simplified. Product of rationals. Okay. This one, we need to go ahead and split them apart. So I would have the square root of -1 times the square root of 10 times square root of -1. And I would think, what are my perfect squares in 15? There isn't any, so square root of 15. I know that the square root of -1 is I, and the square root of -1 is I again. So it's I square root of 10 times I square root of 15. And now I can go ahead and combine them. I would have I times I, which is the same as x times x, which would give us x squared. So this is I squared. And then I can combine underneath the radical sign 10 times 15. So it's the square root of 10 times 15. Simplifying again, I would have I squared square root of 150. Now I would go ahead and think, well, what are my perfect squares in 150? So I would have I squared is equal to 25 times 6. The square root of 25 is 5, so I have 5I squared times the square root of 6. And then lastly, I think, well, what is I squared? Well, if you look on your box on the page before, I squared is just -1. So I would have 5 times -1, or -5 square root of 6. There it is, simplified for part C. Let's try another one for good practice. I would like you to write this one down on your note sheet, and I would like you to try this one on your own. If you go ahead and simplify the practice problem, you should get -30 square root of 30. Okay. Let's go back to D on the notes. Okay. So more with imaginary numbers. So I have -2i times 7i. So you can go ahead and just multiply the parts that are the same. So -2 times 7 gives you -14. And then you would go ahead and multiply I times I, which gives you I squared. And we know that I squared is the same thing as -1. So I would have -14 times -1, which gives me 14. Okay. All right. So we're going to add, subtract, and multiply imaginary numbers. This is actually what we have here is two complex numbers. A complex number looks like this. This part, to be complex, you have to have a real part, and you have to have an imaginary part. So this is a complex number. It has a real and an imaginary. And by real, I think any number that you have thought of before. And imaginary, it has the I involved. So this part that I underlined is a complex number. So we're going to add these two complex numbers, which involve imaginary numbers. So the way you do it is addition. So once again, just think about adding the real parts. So I would have 6 plus 1 gives you 7. And then you have -4i plus 3i. So just like adding x together, if I had -4x plus 3x, I would get -x. So in this case, -4i plus 3i gives me -i. And I can't simplify that any further, so that would be my solution. Little joke off to the side. It's kind of funny. Pi is a rational number because it's involved. It's a rational number. And sorry, pi is an irrational number. It is, and I is an imaginary number. So the pi is telling the imaginary number to get real, and the imaginary is telling the pi to get rational because it is irrational. So B. Once again, here we're going to be subtracting. One thing you need to be careful of is this negative out in front. We are subtracting. So what we have is -2 minus a -1. So it's really going to be +1. So it's really -2 plus 1, which gives us -1. And then we have 5i minus 2i. So 5i minus 2i gives me 3i. So I have -1 plus 3i. And maybe an easier way to think about this one is if there's a negative to just go ahead and distribute it and then add it. So if you want to, you could also think about it as addition, and it would be 1 minus 2y. And you should get the same answer. Now we're going to be multiplying. So let's go ahead and stop the video here for today. We will finish the multiplying C and D together and number 5 in class. So have a nice night, and I will see you tomorrow.